Okay, we're asked to differentiate. So this is just a different way to ask the same question. This function f of x equals x divided by x minus 1. So this is the same definition of the derivative we're doing, but we're just applying it to a new function. Okay, so we have the limit as delta x goes to 0. And f of x plus delta x, we have everywhere we had an x, we're replacing with x plus delta x, right? That's function notation. That's what it means to find f of x plus delta x. So this is going to be x plus delta x over x plus delta x minus 1. And we're subtracting off the actual original function, and all of this is divided by delta x. Okay, so hopefully you're looking at this and anticipating where we're going to go with this. We have a fraction, right? We have a fraction and we want to subtract, so we need a common denominator. So I'm going to multiply this fraction by this one's denominator. So I'd refer you back to earlier problems. I think like number 12, we had to get a common denominator just to emphasize how this process works. So we're looking at multiplying by 1, right? So I'm not changing the value of anything. I'm multiplying by 1. These blue expressions are equal to 1, but it's going to give me the convenience of having a common denominator. Okay, so I have to multiply my numerator here, multiply my numerator here. I'm going to pause and work through some of that algebra. I would encourage you to do the same thing. Okay, so I got a lot written there, so I want you to take a second and maybe pause it again, pause the video again, and look through the algebra I just did. I tried to color code some work here. So I FOILed out or distributed my binomials here to get this expression. Since I'm subtracting, so I did that in purple to emphasize what happened when I subtracted, when I distributed these values, I also had to distribute the negative sign. Okay, so that's all the red is all of the distributing in the numerator. But then also this delta x dividing by delta x is equivalent to multiplying by 1 over delta x. Again, that's something we talked about in an earlier problem. So I can put this delta x up in the denominator. So I'm left with just one fraction. Okay. Okay, again, pause the video as needed to double check math. And I'm going to move on though. So we can cancel some like terms. We have x squared minus x squared. We have x times delta x and then negative x times delta x. And finally we have negative x and positive x. Okay, so what's left? We just have negative delta x in the numerator, and then the denominator is still there. Now, because I'm looking at the limit as x goes to 0 and not at 0, I can cancel that common factor. And so this is going to be equal to the limit as delta x goes to 0 of just negative 1 over x minus 1 times x plus delta x minus 1. This canceling allows me now to do direct substitution. I actually apply the limit, let delta x go to 0, and I'm left with, and notice now that I've applied the limit, I don't write it anymore. I'm left with negative 1 over x minus 1 times x minus 1, or I could write that as x minus 1 quantity squared. So f prime of x, or the derivative of f of x, is negative 1 over x minus 1 squared.